Question 1. What is the primary objective of reproducibility in ML ops? Option A. To ensure that all ML models achieve perfect accuracy. Option B. To recreate the exact same model, outputs, and performance metrics given the same inputs and environment. Option C. To reduce the computational resources required for model training. Option D. To automatically deploy models to production without human oversight. The correct answer is to recreate the exact same model, outputs, and performance metrics given the same inputs and environment. Here's the explanation. Reproducibility in ML ops means being able to recreate an identical model artifact and achieve identical evaluation results when provided with the original training data, code, and computational environment. This is crucial for debugging, auditing, and fair comparisons. Question 2. Which component is crucial for managing and recreating the exact computational environment for reproducible ML experiments? Option A. Git for code versioning. Option B. Data version control, DVC, for datasets. Option C. Docker for containerization. Option D. MLflow for experiment tracking. The correct answer is Docker for containerization. Here's the explanation. Docker, containerization, is crucial for environment management, packaging the application and its dependencies into a standardized unit, ensuring the exact software environment can be consistently deployed and recreated. Git is for code, DVC for data, and MLflow for experiment tracking. Question 3. A key use case for reproducibility in ML ops is debugging and performance regression analysis. How does reproducibility aid this process? Option A. By automatically optimizing model hyperparameters. Option B. By isolating whether performance issues stem from data changes, code bugs, or environmental drift. Option C. By accelerating the initial data ingestion and preparation phase. Option D. By providing real-time predictions to end users. The correct answer is by isolating whether performance issues stem from data changes, code bugs, or environmental drift. Here's the explanation. Reproducibility allows engineers to recreate the exact training conditions of a model, enabling them to isolate the root cause of performance degradation by systematically testing if the issue is due to changes in data, code, or the environment. This greatly aids in debugging. Question 4. In ML ops, what does scalability primarily refer to? Option A. The ability of an ML system to reduce costs by always using the smallest possible compute instances. Option B. The ability of an ML system to effectively handle increasing workloads across its lifecycle without compromising performance or efficiency. Option C. The process of deploying ML models to multiple geographic regions simultaneously for disaster recovery. Option D. The capability to manually adjust compute resources based on a fixed schedule, regardless of demand. The correct answer is quote, the ability of an ML system to effectively handle increasing workloads across its lifecycle without compromising performance or efficiency. Here's the explanation. Scalability in ML ops is the ability of an ML system to manage increasing workloads, e.g., data volume, inference requests, model complexity, across all stages of its lifecycle while maintaining performance and efficiency. Question 5. An e-commerce company experiences significant spikes in inference requests for its recommendation engine during holiday sales. To ensure low-latency recommendations under extreme load, which combination of MLOps components is most critical for achieving scalable inference? Option A. Manual provisioning of single, large GPU instances and storing model artifacts in local disk. Option B. Apache Spark for data processing and SageMaker Debugger for real-time monitoring. Option C. Containerization, Docker, with orchestration, Kubernetes, and auto-scaling mechanisms based on real-time metrics. Option D. Utilizing serverless functions for batch processing and traditional relational databases for feature storage. The correct answer is containerization, Docker, with orchestration, Kubernetes, and auto-scaling mechanisms based on real-time metrics. Here's the explanation. Containerization and orchestration, like Kubernetes, provide portable and manageable deployments, while auto-scaling based on real-time metrics dynamically adjusts the number of serving instances to handle fluctuating demand, which is crucial for low latency and highly available inference. Question 6. Which statement accurately differentiates between vertical and horizontal scaling in the context of MLOps? Option A. Vertical scaling involves adding more instances, while horizontal scaling involves increasing resources, CPU RAM, of a single instance. Option B. MLOps primarily focuses on horizontal scaling for distributed workloads, whereas vertical scaling is less common for production ML systems. Option C. Vertical scaling is ideal for distributed training frameworks, while horizontal scaling is best suited for single-node inference. Option D. Horizontal scaling is more cost-effective for initial prototyping, while vertical scaling is preferred for large-scale production deployments. The correct answer is MLOps primarily focuses on horizontal scaling for distributed workloads, whereas vertical scaling is less common for production ML systems. Here's the explanation. Vertical scaling, scaling up, means adding more resources to a single instance. Horizontal scaling, scaling out, means adding more instances. MLOps predominantly uses horizontal scaling to distribute workloads across multiple nodes for better elasticity and cost efficiency. Question 7. What is the primary objective of MLOps governance? Option A. To accelerate model training times by optimizing compute resources. Option B. To streamline the deployment of ML models into production without manual intervention. Option C. To ensure ML initiatives align with business goals, adhere to regulations, mitigate risks, and uphold ethical AI principles. Option D. To automatically retrain models when their performance degrades in production. The correct answer is to ensure ML initiatives align with business goals, adhere to regulations, mitigate risks, and uphold ethical AI principles. Here's the explanation. The overview states, the primary objective of MLOps governance is to ensure that ML initiatives align with business goals, adhere to regulatory requirements, mitigate operational and reputational risks, and uphold ethical AI principles. Question 8. Which MLOps governance component is crucial for tracking every iteration of a model, including training data, code, hyperparameters, and deployment history, to ensure reproducibility and provide an auditable trail? Option A. Role-based access control, RBAC. Option B. Data governance for ML. Option C. Model monitoring and alerting. Option D. Model versioning and lineage. The correct answer is model versioning and lineage. Here's the explanation. The key features/components section defines model versioning and lineage, tracking every iteration of a model, including the training data, code, hyperparameters, environment configurations, and deployment history, to ensure reproducibility, facilitate rollbacks, and provide an auditable trail. Question 9. How does MLOps relate to ML governance? Option A. MLOps defines the rules and policies, while ML governance provides the tools and infrastructure. Option B. MLOps and ML governance are interchangeable terms for the same set of practices. Option C. MLOps provides the technical mechanisms and infrastructure to operationalize ML, while ML governance defines the rules, policies, and oversight that guide these processes. Option D. MLOps is solely focused on model training, while ML governance is only concerned with post-deployment monitoring. The correct answer is MLOps provides the technical mechanisms and infrastructure to operationalize ML, while ML governance defines the rules, policies, and oversight that guide these processes. Here's the explanation. The comparison-related concepts section states, MLOps provides the asterisk mechanisms and time infrastructure to operationalize ML. ML governance represents the asterisk rules, policies, and oversight that times guide and constrain times the MLOps processes. It defines what should be done and how it should be done to ensure compliance, ethics, security, and accountability. Question 10. What is the fundamental difference between structured and unstructured data, particularly concerning their schema definition? Option A. Structured data uses a schema-on-read approach, while unstructured data has a predefined, rigid schema-on-write. Option B. Structured data is always stored in text files, while unstructured data is always in databases. Option C. Structured data has a predefined, rigid schema-on-write, while unstructured data lacks a predefined schema or uses a schema-on-read approach. Option D. Structured data requires deep learning models, while unstructured data uses traditional machine learning algorithms. The correct answer is structured data has a predefined, rigid schema-on-write, while unstructured data lacks a predefined schema or uses a schema-on-read approach. Here's the explanation. The key distinction is that structured data adheres to a predefined schema enforced at write time, schema-on-write, typically in tabular form, whereas unstructured data lacks a fixed schema and its structure is interpreted, if at all, at read time, schema-on-read. Question 11. When an MLOps pipeline processes unstructured text data, e.g., customer reviews, for sentiment analysis, which of the following is a characteristic preprocessing step distinct to this data type? Option A. Normalizing numerical features using min-max scaling. Option B. Performing SQL joins to combine data from multiple tables. Option C. Tokenization, stemming/lemmatization, and generating word embeddings, e.g., using BERT. Option D. ensuring ACD properties for database transactions. The correct answer is tokenization, stemming, slemmatization, and generating word embeddings, e.g., using BERT. Here's the explanation. For unstructured text data, specific NLP techniques like tokenization, stemming/lemmatization, and generating embeddings, e.g., word2vec, BERT, are essential to transform the text into a numerical format suitable for machine learning models. The other options are relevant to structured data or database operations. Question 12. An organization is building an MLOps pipeline that needs to store raw, untransformed data from various sources including IoT sensors, website clickstreams, and social media feeds, which consist of structured, semi-structured, and unstructured formats. Which storage solution is best suited for this requirement? Option A, a traditional relational database, e.g., PostgreSQL. Option B, a highly optimized data warehouse, e.g., Amazon Redshift. Option C, a data lake utilizing object storage, e.g., Amazon S3, Azure Blob Storage, Google Cloud Storage. Option D, a key value store for rapidly accessing single records. The correct answer is a data lake utilizing object storage, e.g., Amazon S3, Azure Blob Storage, Google Cloud Storage. Here's the explanation. Data lakes, typically built on scalable object storage services, are designed to store raw, untransformed data of all types, structured, semi-structured, unstructured, without imposing a schema, making them ideal for the diverse data needs of MLOps, especially for unstructured data. Relational databases and data warehouses are primarily for structured, predefined data. Question 13. What is the primary role of data ingestion in the MLOps lifecycle? Option A, to perform complex feature engineering and model training on raw data. Option B, to deploy trained machine learning models into production environments. Option C, to collect and bring raw data from various disparate sources into a target system for storage and processing. Option D, to monitor the performance of deployed models and detect anomalies. The correct answer is, quote, to collect and bring raw data from various disparate sources into a target system for storage and processing. Here's the explanation. Data ingestion is the foundational and critically important process responsible for collecting and bringing raw data from various disparate sources into a target system, where it can be stored, processed, and subsequently used for machine learning model training, validation, and inference. Question 14. A company is building an MLOps pipeline for a real-time fraud detection system that requires processing high-volume, low-latency transaction data. Which ingestion mechanism and target storage type are most appropriate for the raw data? Option A, batch processing into a traditional relational database. Option B, streaming ingestion into a data lake. Option C, incremental loading into a data warehouse. Option D, manual file uploads to a local server. The correct answer is streaming ingestion into a data lake. Here's the explanation. Real-time fraud detection demands low-latency processing, making streaming ingestion ideal. Data lakes, e.g. S3, ADLS GCS, are highly scalable and cost-effective for storing high-volume raw data in its native format, suitable for subsequent real-time or batch processing by ML models. Question 15. Which critical practice should be integrated into data ingestion pipelines to prevent corrupted or malformed data from polluting downstream ML processes? Option A, decoupling storage and compute. Option B, continuous integration/continuous deployment, CI/CD. Option C, comprehensive data validation and schema adherence checks. Option D, using only NoSQL databases as data sources. The correct answer is, quote, comprehensive data validation and schema adherence checks. Here's the explanation. Validating data quality, schema adherence, and completeness at the point of ingestion is critical. Catching issues early prevents corrupted or malformed data from propagating through the entire ML pipeline, saving significant time and resources. Question 16. What is the defining characteristic of batch processing in the context of ML ops? Option A, it processes individual data points with ultra-low latency. Option B, it handles continuous, unbounded streams of data in real time. Option C, it accumulates data over a period and processes it in discrete, non-real-time chunks. Option D, it requires persistent, always-on compute resources for immediate responses. The correct answer is, it accumulates data over a period and processes it in discrete, non-real-time chunks. Here's the explanation. Batch processing involves accumulating data over a period and then processing it all at once in discrete chunks. This contrasts with real-time online processing, A. D, which handles individual requests with low latency, and streaming processing. B, which continuously processes data as it arrives. Question 17. Which of the following strategies is least aligned with cost optimization principles for large-scale batch processing in MLOps? Option A. Utilizing spot instances or preemptible VMs for compute resources. Option B. Scheduling batch jobs during off-peak hours to leverage lower demand. Option C. Maintaining always-on dedicated compute clusters sized for peak loads, regardless of current workload. Option D. Implementing auto-scaling policies to provision and deprovision compute resources based on workload demands. The correct answer is maintaining always-on dedicated compute clusters sized for peak loads, regardless of current workload. Here's the explanation. Maintaining always-on compute clusters for peak loads is inefficient for batch processing, as resources sit idle during off-peak times, leading to unnecessary costs. Strategies like using spot instances, scheduling off-peak, and auto-scaling are all designed to optimize costs by only paying for resources when they are actively used. Question 18. A media company needs to retrain its content recommendation model every week using all newly accumulated user interaction data and content metadata. This process involves fetching terabytes of data, extensive feature engineering, and then training a new model version. Which MLOps approach is most suitable for this task? Option A. Real-time streaming for continuous model updates. Option B. Online inference endpoint for immediate model serving. Option C. Batch processing for periodic model retraining. Option D. Manual, ad hoc model updates by data scientists. The correct answer is batch processing for periodic model retraining. Here's the explanation. Periodic model retraining on large, accumulated datasets is a quintessential use case for batch processing. It allows for efficient, scheduled updates to models without requiring real-time processing, handling the extensive data preparation, and training in bulk. Real-time streaming and online inference are for immediate data or prediction needs, and manual updates lack scalability and automation. Question 19. In the context of MLOps, what is the primary reason for incorporating streaming data capabilities into a machine learning pipeline? Option A. To perform historical batch analysis of large, static datasets. Option B. To enable real-time inference, continuous model adaptation, and immediate performance monitoring for ML models. Option C. To reduce the overall complexity of data storage and management. Option D. To eliminate the need for any data pre-processing steps before model training. The correct answer is to enable real-time inference, continuous model adaptation, and immediate performance monitoring for ML models. Here's the explanation. Streaming data is crucial for MLOps to allow models to make predictions or decisions as events unfold, real-time inference, to update or retrain models with fresh data, continuous learning, and for real-time monitoring of model performance and data quality. Question 20. Which component in a typical streaming data pipeline for MLOps is responsible for acting as a scalable, durable buffer that decouples data producers from consumers and ensures message ordering? Option A. Stream processing engine. Option B. Feature store. Option C. Data ingestion layer. Option D. Model serving endpoint. The correct answer is data ingestion layer. Here's the explanation. The data ingestion layer, e.g., Kafka, Kinesis, PubSub, is a highly scalable, durable, and fault-tolerant service that acts as a buffer and message broker, decoupling producers from consumers and ensuring data delivery and ordering. Question 21. A financial institution needs to analyze every transaction as it occurs to immediately identify and block potentially fraudulent activities. Which MLOps use case demonstrates the critical role of streaming data in this scenario? Option A. Training a fraud detection model on monthly aggregated transaction data. Option B. Generating daily reports on the total number of fraudulent transactions from a data warehouse. Option C. Using a stream processing engine to perform real-time feature engineering and invoke a model serving endpoint for immediate fraud prediction. Option D. Storing all transaction data in an object storage for future historical analysis. The correct answer is using a stream processing engine to perform real-time feature engineering and invoke a model-serving endpoint for immediate fraud prediction. Here's the explanation. Real-time fraud detection is a prime MLOps use case for streaming data, as it requires immediate analysis of transactions and predictions to trigger alerts or actions, like blocking a transaction, within milliseconds, which is enabled by stream processing and real-time model serving. Question 22. The transform phase of an ETL pipeline in MLOps is uniquely critical due to its emphasis on which of the following activities? Option A. Connecting to diverse data sources like operational databases and streaming platforms. Option B. Writing process data into a target destination optimized for analytical workloads. Option C. Performing extensive feature engineering to improve machine learning model performance. Option D. Defining and managing the sequence of ETL jobs and their dependencies. The correct answer is performing extensive feature engineering to improve machine learning model performance. Here's the explanation. The study material explicitly states that the transform phase is where the magic happens for ML, and highlights feature engineering as a critical ML ops specific component, involving creating new input features to improve model performance. Question 23. In an ML ops context, which of the following is a primary destination for processed, clean, and feature engineered data during the load phase, specifically designed to ensure consistency between training and inference environments? Option A. Operational databases. Option B. Raw data lakes. Option C. Specialized feature stores. Option D. Streaming platforms. The correct answer is specialized feature stores. Here's the explanation. The study material states that, crucially for MLOps, processed features are often loaded into a feature store, ensuring consistency between training and inference environments and enabling feature reuse across multiple models. Question 24. A data engineer is designing an MLOps pipeline where raw data from various sources needs to be ingested quickly into a scalable storage system before any complex transformations are applied. The transformations will then be performed using the compute capabilities of the target system. Which data integration paradigm is being described? Option A. ETL. Extract, transform, load. Option B. ELT. Extract, load, transform. Option C. OLAP. Online analytical processing. Option D. OLTP. Online transaction processing. The correct answer is ELT. Extract, load, transform. Here's the explanation. The study material defines ELT as extracting and loading raw data first into a highly scalable storage system, like a data lake or cloud data warehouse, and then transforming it within times that target system using its compute capabilities. This contrasts with ETL, which transforms data before times loading. Question 25. What is the defining characteristic of the ELT, extract, load, transform paradigm compared to ETL, extract, transform, load in an ML ops context? Option A. Data transformation occurs on a dedicated staging server before loading into the target system. Option B. Raw, untransformed data is loaded directly into a scalable target system before transformation. Option C. Data is always fully transformed in real time during the extraction phase. Option D. It is primarily used for small, highly structured datasets with strict schema requirements. The correct answer is, quote, raw, untransformed data is loaded directly into a scalable target system before transformation. Here's the explanation. The overview states, unlike its predecessor, ETL, extract, transform, load, ELT prioritizes loading raw, untransformed data directly into a scalable target system, typically a cloud data lake or data warehouse, before performing any significant data transformations. Question 26. Which of the following best describes why ELT is particularly well-suited for cloud-native environments and MLOps? Option A. It relies on traditional, fixed-capacity, on-premise servers for transformations. Option B. It leverages the inherent scalability, elasticity, and processing power of modern cloud data platforms. Option C. It mandates strict schema-on-write principles, limiting flexibility for diverse data types. Option D. It requires manual data extraction and loading processes, reducing automation. The correct answer is, it leverages the inherent scalability, elasticity, and processing power of modern cloud data platforms. Here's the explanation. The overview states ELT leverages the immense scalability, elasticity, and processing power inherent in modern cloud data platforms. Also, scalability and elasticity is a key feature, and flexibility and schema on read is another. Question 27. In the transform phase of an ELT pipeline for MLOps, what critical activity is performed to prepare data for machine learning models? Option A. Extracting data from source systems without any modification. Option B. Loading raw, untransformed data into a cloud data lake. Option C. Performing feature engineering, data cleaning, and aggregation within the target environment. Option D. Sending model predictions to downstream applications. The correct answer is performing feature engineering, data cleaning, and aggregation within the target environment. Here's the explanation. The How It Works section for the transform phase highlights. For MLOps, this phase is critical for cleaning and validating data, aggregating data, joining data, performing feature engineering, normalizing or standardizing features. Thanks for watching. Please subscribe to my channel.